The network was a bit low for me to join on the Zoom, but now I switched the network. Let's continue. So as I was explaining, the last part we are focusing on now is for calculating the x-intercepts of the cubic function. So it's the same way, the way we calculate the x-intercepts, the first step is the same. What is different is other steps going down. So if our network is giving us problems, let me know so that I switch the network immediately, right? Are you with me?
Yes.
All right. So now we want to calculate the x-intercepts of the cubic function. So you need to let g of x, which is the same as y, to be equal to 0. Why? Because we know at the x-intercept, y is equal to 0. So hence we let g of x to be equal to 0 then. So here I was explaining that you are allowed to exchange the positions of this. So instead of writing 0 equal to that, you can write this equal to 0. It's the same thing. And then whenever you see a negative, you must panic. What you're supposed to do there is just to divide everything by negative so that you are now left with a clean equation of which we can be able to deal with. All right. Then from there, I'm going to explain something which is very important of how do you find the x-intercepts here. So that is with factorization. Here, quadratic formula doesn't work. We have to use quadratic formula. Get me right on that one. On this cubic function, to deal with cubic equation, we are not allowed to use quadratic formula. The only method we can use is factorization. I believe you got me clear on that statement. We have to use factorization. Cubic formula, quadratic formula doesn't work on this. So then now, this is how you apply the factorization on that equation. So that is what we are going to do just now to apply the factorization. So the first thing we do is to find the factors of this expression. So now, the first thing which you need to know about the factors is that a factor is a number which, when you substitute wherever we have x here, this expression is going to be equal to 0. That is called a factor. Let me define it again. A factor is any number which, when you substitute wherever we have x on this expression, this left-hand side is going to be equal to 0 on the right-hand side. Are we together on that one?
Please explain it again.
All right, let me repeat it again. A factor or factors are numbers which, when you substitute where we have x on this expression here, when you substitute the value of x, you are going to get 0. For an example, if we substitute 2 on the x, you substitute 2 here, you substitute 2 there, you substitute 2 there, and then you get a 0 after simplification. Therefore, that number which you substitute is then called a factor. So in order to factorize this, you must get a factor first. Are we together?
Yes.
All right. So then now I want to simplify for you. How do we find factors? Factors are numbers which are product of this. For example, factor of 1 is 1 times 1. So therefore, in this case, you are going to substitute the value of 1 in order to assess if indeed, when you substitute 1 here, you're going to get 0. For sure, it can be 1, positive 1 and 1, or negative 1 and negative 1. All those can be factors. But let's just give an example. If instead of having 1 here, we had 4. So if you had 4, numbers which you're going to test as factors, it was going to be 2, and then the other numbers were going to be -2, and then the other numbers were going to be 4 and 1, and -4 and 1. So these were the factors which you're going to test, or the numbers which you are going to test if it's a factor. You substitute 2 and assess if when you substitute 2, you're going to obtain 1. If it is not 1, you substitute another 1. You substitute -2. You check if you are going to get a 0. If it's not 0, it's not a factor. You substitute 4. If you're not getting 0, it's not a factor. You substitute 1 up to so on. But here we are fortunate because this constant is 1. So you either have a factor of -1 or a factor of 1. So let's start by using a factor of 1. If we substitute 1 wherever we have x on this expression, do we get 0?
Yes.
Very true. You are going to get 0 here. You substitute 1 wherever we have x, you're going to get 0. Therefore, x equal to 1 is a factor. So this 1, you take it to the other side. You are now going to have x minus 1. You get a factor of x equal to 1. Then after obtaining the factor you are looking for, you then take this 1 to the other side and you have x minus 1. So that is your first small bracket. So we have first small bracket. After having small first bracket, on the other side, you're going to have big bracket. These brackets are not of the same size. This bracket is small and that bracket is big. You will see why we write big bracket there. So I'm going to explain an approach which is a bit complex, but bear with me. That is how we're supposed to deal with this. So now this is what you do in order to fill expressions on this big bracket. So you divide this x cubed up here with this x we have there. So x cubed divided by x, what is it? What is x cubed divided by x?
X squared.
You are going to have x squared. Therefore, that x squared, you write it there. And from there, you skip any term in between here. You go to the last term. So you say this 1, you divide it with -1. What is 1 divided by -1?
-1.
Is -1, right? Remember, we skipped some terms in between here and we jumped to the last term. So after doing so, we then have to add plus bx then. So we add plus bx. We have x squared, which we obtain by saying x cubed divided by x, and we obtain x squared. We jump all the terms in between. We go to the last term. We say 1 divided by -1, we obtain -1. Therefore, on the middle term, we then have bx. So after doing so, we can then simplify this expression, of which at later stage we're then going to obtain the value of b. Let's do that and see what we obtain. So we multiply x with x squared, we will obtain x cubed. We multiply x with bx, we will obtain plus bx squared. We multiply x with -1, we will obtain -x. We multiply -1 with x squared, we obtain -x squared. We multiply -1 with bx, we obtain -bx. We multiply -1 with -1, we obtain +1. And then that is equal to 0. So from there, we can add like terms, of which we're going to have x squared, this with that at like terms, so you can group them together. When you group them together and take out the common factor, we're going to have b minus 1 x squared. Yes.
The screen is not that visible.
All right. Yes, I think it's very because of the internet. Let me try to do something here. Is it okay now? Is the screen okay now?
Yes.
All right.
Yes.
All right, wonderful. Let's go further. So now, let me explain this part again because it's very important. This x must multiply everything we have on the second big bracket. So we multiply x with x squared, we obtain x cubed. We multiply x with bx, we obtain bx squared. We multiply x with -1, we obtain negative x. We multiply this -1 with everything inside the big bracket. So it means we're going to have -1 times x squared, which will give us x squared, negative x squared. We multiply -1 with bx, we obtain negative bx. We multiply -1 with -1, we obtain +1. Then from there we add like terms. These and that are like terms. The other one is having coefficient of b, other one is having coefficient of -1. So you can just take out the common factor. So you'll have b minus 1 into x squared. You group these two terms and then we group the like terms again. These term and that term are the like term. So you can group them together. So it means you're going to have plus into -1 minus b x. And then the last term is +1. It's a constant. So then after having that, you are only left with a simple job to do here, is to compare the coefficients. So the coefficients of this expression we have down here with the coefficient we have up there. So coefficient must be the same. So here we have coefficient of 1 and then we have coefficient of 1. Therefore, that is fine. So coefficient of b minus 1, it must be equal to the coefficient of x squared. So it means you're going to have b minus 1 equal to -1. So then you take this -1 to the other side, you're going to have b, which is equal to -1 plus 1. And by that, you have obtained the value we are looking for, of which is the value of b. So therefore, b is equal to 0 here. You must substitute up there. So if you substitute up there, you're going to have x minus 1. You're going to have x minus 1, x squared minus 1 equal to 0. We are now left to factorize that. It's going to be x minus 1. Then we factorize the second bracket. It's going to give us x, 1, 1, positive, and then negative. So in summary, the x-intercepts here, they're going to have x equal to 1 or x equal to -1, of which you can write as a coordinate. So you're going to have a coordinate of 1 is to 0 or -1 is to 0. So that's how you calculate. That's how you calculate the x-intercepts. I know we did not cover that fully. We are going to do more examples tomorrow with regard to this because it's very important. You must know how to deal with cubic functions. So, but today we have covered two major things. The first one is for calculating the turning point, of which you must go and revise how to calculate the turning point. The second one is how to calculate the x-intercepts, of which this we did not cover fully. We'll do tomorrow again. And then the other part which is coming after this is for drawing the cubic function. So that part I'm going to cover with you tomorrow. Make sure you revise what we have covered today so that when we plot the cubic function tomorrow, you are not going to have any problem. So because of time, let's stop here for today. We will meet tomorrow to finish up this section. So otherwise, from my side, have a wonderful night. Goodbye.
Thank you. Bye.
I'll give you a homework. I'll send a homework.
All right.
All right. Bye.